Hey everybody, good to see you again. Or not see you again. This is Chapter 5, Section 2, the Probability Rules. There'll be lots of things to write down, and we will be sure to go over these things in class to help you understand what they mean. Sample space and the probability model. A sample space, which is always denoted as a capital S, is a set of all possible outcomes. The probability model is a description of some chance process that consists of the sample space and the probability of all possible outcomes. So you have a sample space and you have the probability model, and the probability model describes the probability of all the possible outcomes. Okay, so here's an example. Imagine flipping a coin 3 times. Can you give the probability model? Well, this would be the sample space. You can get 3 heads. You can get 2 heads and a tail. Head, tail, head. Tail and 2 heads. A head and 2 tails. Tail, head, tail. 2 tails and a head, or 3 tails. Those are all the different things that can happen when you flip a coin 3 times. Because there are 8 possible outcomes and every outcome has an equal chance of happening, so therefore each sample has a 1/8 probability. That would be the probability model. An event is a collection of outcomes. An event is a subset of the sample space. Usually it's designated as a capital letter. Alright, here are some basic rules for probability. For any event A, the probability of A, that's how you would read P with that's how you would read this right here. The probability of A is a number in between 0 and 1, and also including 0 and 1. All possible outcomes in an event must add up to 1. For example, you can't say, when you add up all the probabilities of pulling red coins out of a bag or green coins, whenever you add up all the probabilities of the event, they have to add up to exactly 1. If all the possible outcomes of an event are equally likely, then the probability can be found by the probability of A is equal to the number of outcomes corresponding to event A over the total number of outcomes in a sample space. The sum of the probabilities of an event and the probability of its complement is 1. So this is how you denote complement right here, A with and then you would say with a little superscript of C. So the probability of the complement of A is equal to 1 minus the probability of A itself. So if there's a 70% chance it was going to rain outside, the complement would be it not rain. So I would know that 1 minus 70%, or 1 minus 0.7 would give me 0.3 or 30%. So either it rains or it doesn't. So that's why an event and its complement always have to add up to 100% or 1. If 2 events have no outcome in common, the probability that one or the other occurs is the sum of their individual probabilities. These 2 events are said to be mutually exclusive. 2-way table, I'm sure you've seen these before. It's a display of data that can make finding probabilities a little easier. So here is a collection of data of boys and girls in a classroom maybe, and their hair color. So the colors were black, blonde, brown, and red, and it's easy to see in this 2-way table the number of boys that had black hair and the number of girls that had brown hair, and then we can find their overall probability by finding the total of all the kids that were in the classroom. The general addition rule says that if A and B are any 2 events resulting from some chance process, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. I'll show you what that means in a little bit. Venn diagram is another type of diagram that visually shows relationships between events. I'm sure you've seen Venn diagrams before. So here's an event and its complement. So this is how you would visually show in a Venn diagram. An event is the circle with the A inside, and A with an apostrophe is another way you can denote complement, but our book will usually put a little C up there. And the complement is everything that's not inside A. Usually we talk about that this rectangle is the entire universe, or everybody that could be in there. If you have mutually exclusive events, then again, here's your universe is everything everything you care about, or all your sampling is in the box, and then we have A and B, and they have no events in common. That's why they are mutually exclusive. When you have an intersection of A and B, it is denoted as A intersection B. You could read that as A intersection B. It looks like an upside down U. And then we also have the union, which is denoted as A with a UB. Okay, union U. And what that is denoted by everything in A and everything in B. If A or B are any two events resulting from some chance process, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. This is what we had on the previous page, so you don't have to write that again. But now, because we know those symbols, we can write it like this, and this is how you usually see it, and how it will be on your formula sheet. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A intersection B. And that's it for today.